Hello, my name is Janos. I'm a mechanical engineer by trade. I've been working in the field of machinery vibration monitoring and analysis for about 25 years. Since 2018, I've been working for RDI Technologies, promoting the new motion amplification technology as a complementary tool to our existing predictive maintenance toolkit. In this video, I would like to make a brief introduction of the technology, followed by a couple of interesting cases that I would like to share. An easy way to get started is to look at a car engine starting up. Here is a basic explanation of what happens. The screen shows two videos. Both are slowed down, and the video on the left is the visual image, and the video on the right is enhanced with the motion amplification algorithms. In a nutshell, we can see the vibration thanks to the recordings by 2.3 million pixels acting as vibration sensors. This 3600 RPM electric motor driving a critical blower has continued to show high vibrations despite a realignment. Taking a look with motion amplification, we notice that the motion is mainly vertical, and that the motor is moving more than the blower, and they seem in phase. So this would not be the expected behavior of parallel misalignment. These types of blowers use external air, and with seasonal temperature changes, the thermal expansion at the inboard end is often affected. The next step is to take a wider view and see what is happening. The motion amplified clip is shown on the right hand side. We can see that the motor shows no looseness and moves as one, but the large skid beam seems immobile. Zooming in now to the beam interface, a crack through the weld becomes apparent. There also seems to be a break in the upper left corner of the image, if you can spot it. A cracked base would add mobility, possibly change the system resonances, and can compromise the alignment. Taking more views, further cracks become apparent, here showing one at the rear of the machine. In total, we find 3 cracks, plus the one in the middle of the machine. Here we can see the results of the repairs. With the video evidence, the corrective actions required were easy to communicate. Here is a record of the vibration trends. We can see that over time, there was a fair amount of vibration amplitudes, often above 0.4 inches per second peak. Over time, vibration will induce fatigue in the machinery and structures. We can see the large peak on the right side where the problems start having a big impact. At the end, the machine is put back into service with historically lowest levels of vibration. This second case study is of a typical fan. You will notice the video is looped and the beginning shows the visual unamplified footage, then amplification is turned on. We can notice that the motor is rocking back and forth on a fairly flexible structure. The motor sheave is likely a source of unbalance, so we will take a look there next. We can see the motor and its sheave rocking back and forth, but what can be the cause of it? We now use a different recording, without amplification, to visualize the sheave in slow motion. The keyway seems rather empty, and could very well be the source of unbalance. We can also take a shaft displacement measurement on the sheave, and track how the keyway actually seems to be acting as a light spot, in effect showing that opposite the keyway is the heavy spot. This footage can serve as a good testimonial to potentially reinforce the base, and also cut a shaft key of appropriate weight and proportions. Often the results of vibration analysis can be uncertain and difficult to explain. This can cause delays in resolving high vibration events during commissioning of new equipment or during routine surveys. There are also cases where machines are difficult to access or structures are very large or we need shaft displacement readings. To get more value out of a vibration analysis program, motion amplification helps understand and resolves the issues correctly. I recorded this video for the spring 2020 edition of the CMVA VIBS newsletter. I hope you had as much fun watching it as I did making it. Should you have any questions regarding the content, please feel free to contact me at the following phone number or email address.